The real insight from this article, that is the thing that made me excited and is very applicable to MakerDAO, is that if you know what you are looking for, you actually can understand these very complicated protocols quite easily, right? Once I had done this categorization for Maker that I understood and Yield that I understood, and Compound V2 is like, hold on, this is incomplete. I need to do it also for Compound V1, Aave V1, and so on. But I knew what I was looking for. So I could go, okay, so Compound V1, where is the treasury? Here. The accountant, here. Where's the oracle? Here. Okay, so this is how they do it. It all maps out. You can go to MakerDAO and just track all those functions, and you will have a mental image of how it works, which is great.
On this episode, we talked with Alberto, who is the co-founder and tech lead of Yield Protocol. Kevin, I'm curious what stood out to you about this app.
Yeah, this was a neat episode because we basically synced up on Farcaster, and he had put out a blog post called Borrowing on Ethereum, comparing architecture evolution of MakerDAO, Yield, Aave, Compound, and Euler. And so he dug into that blog post and gives a really concise timeline of all of the innovation that has happened in DeFi over the last few years and talks about kind of the major protocols. We talk a lot about DeFi Summer. And it was really neat to compare and contrast the different design decisions that each of those protocols took throughout version 1, version 2, version 3. So I did a lot of learning about DeFi in this episode. And I think it's just a really cool episode if you're into that sort of a thing.
Totally. It was a very sort of comprehensive history of how smart contract architecture as it relates to DeFi has evolved over time. So this was a really fun one. It truly felt like we were talking through a chronological timeline because we were. And so, yeah, hopefully you enjoyed this episode as much as we enjoyed recording it with Alberto. Let's jump into it. We are here with Alberto, who is the co-founder and tech lead of Yield Protocol. Alberto, thanks so much for coming on the pod. We're very excited to have you.
Hi, everyone. I'm thrilled to be here.
GM, thank you.
I am super excited to talk about the evolution of borrowing on Ethereum. You wrote this incredible article sort of detailing how borrowing on Ethereum has been implemented over the last few years from basically a mechanism design and contract level. And we're going to dive into that timeline today. But maybe before we even get started, a little bit of helpful context might be how you got into DeFi and how you ended up building Yield Protocol, particularly in the context of this borrowing on Ethereum conversation. I think background is always helpful.
That's a very long story, and I have another article for that. But long story short, after doing a bunch of stuff on DeFi for random people, nothing important, but I managed to land a couple of contracts with Open Zeppelin to build stuff, and I had a number of heated conversations on some forums about how to build fixed point math on Ethereum. That's what nerds do, have heated conversations about that kind of stuff. It happened that Alan Nimmer, the other co-founder of Yield, he had got some seed funding from Paradigm to build Yield Protocol, and that included some complex math. And he's just started Googling, and he saw that half of all internet discussing fixed point math was me and a Russian dude. So basically, he contacted me. He asked me to help him a little bit with the math. He sent me the white paper. He sent me the code. I looked at the code. I rewrote the whole thing because it was awful, disgusting. I went back and said, Alan, sorry, but I cannot implement anything in this kind of conditions. I re-implemented it this way. Now we can start talking about the math. And he hired me. Well, he hired me. Employee number 1, became founder later on. As an interesting twist to the story, when it came the time to actually implement the math, I saw that it was way above my head because I had failed doing that before. So I contacted the Russian, and the Russian dude actually did the math. That's how it started. Well, that's how it started in Yield Protocol, which basically is kind of the basis for this article, because Yield Protocol is a lending market. Half of it is a lending market. And to implement it, I had to understand how MakerDAO worked. I didn't get Compound, or Aave didn't exist then. And then by the end of Yield Protocol, that now is sadly winding down, that's also a reason for me to write this article, because I realized that I have a significant knowledge on how to build a lending protocol. I've done 2 versions of this one. And I thought in writing an article to basically teach people how to build a lending protocol with the things I had learned. And as things usually go, when you try to teach something, the first thing that you notice is how many things you actually don't know. So I had to go into Compound and Aave and Euler to see, hold on, we do it this way, but how did they do it? And basically that way, the whole article came together on how each one of the protocols builds the basic same 7 things. And the whole evolution that, look, these are, you can see the innovations, how they appeared. I didn't expect that when I was writing the article, right? I was just saying, I do this, he does that. But then I said, okay, so Compound 2 does it this way, but there's a Compound 3. How they do it? Oh, very interesting. Let's see how the Compound V1 do it. Oh, very interesting. You can see that they learned this thing and then did this thing. So then I started just mapping the same for MakerDAO, then Yield, Compound, the 3 versions, Aave, the 3 versions, and then Euler at the end. That's the story.
I respect the flow of wanting to teach something and then coming to the realization of like how little you know about it. I think it's such an important flow to get into, because I think you've done some work as an instructor at Beyond Skills. You've done some judging at Code Arena. It sounds like you're a full-time developer, part-time teacher, or maybe even like full-time teacher. I'm not sure. Like, it sounds like you do a lot of teaching. And so it was neat to read your article. So for those listening, the blog post itself is called Borrowing on Ethereum, Comparing Architecture Evolution of MakerDAO, Yield, Aave, Compound, and Euler. And so in this blog post, you set the target audience as developers, architects, and security researchers. So you talked a little bit about what the impetus was for writing this post. I think we're going to spend the majority of this episode going through a timeline that you wrote out of the major innovations in DeFi over time, and specifically in the borrowing world of DeFi. But before we do that, could you paint maybe just like a high level picture of the landscape of DeFi and maybe any important concepts going into it? I know the very beginning of the article, you talk about over collateralization. Before we go in super deep, just like high level learnings from writing that article.
Yeah, sure. So there are 2 things that I could probably explain first. First is how protocols are built through the versions, right? How a startup happens, why Compound has 3 versions and Uniswap has 3 versions, then 4 and so on. So every blockchain startup starts with an idea. I want to do this. No one is doing it. It's great. And that comes as a proof of concept, right? And those tend to be the first versions where you are trying to do something. You don't know what's going to happen. You don't know how to do it. So you just put something out, right? Those first versions, Compound V1, Aave V1, Yield V1, the single collateral MakerDAO, sometimes they get traction, sometimes they don't, but basically they are a very limited time kind of application. Then with that, you learn whether the proof of concept makes sense, whether people are interested, and how to actually do something reasonable. People do the second version, Compound V2, very successful, Aave V2, very successful, Uniswap V2. And on that one is like, okay, the proof of concept worked. So now we are going to do something to get traction, to get volume. And if things go well, didn't go for Yield V2, but did for Compound V2 and Uniswap V2 and so on, you grow. You learn the lessons of the proof of concept, and now you can build something that can grow and get volume. And that volume has other lessons that you couldn't get with the small size POC. That is then when a V3 comes along that is, okay, we know what we are building. We know what happens when we actually are successful. Now we are going to do it right? And then you have Compound V3, Aave V3, Uniswap V3 that are much more refined applications. So that's why there is that evolution. That's one side that is important in understanding how all this works. What are we going to find in the first versions of the applications, and what are we going to find in the later ones? And the other thing that is I would take from the article is how is a lending, a CDP, collateralized debt platform built in Ethereum. And there are only a few components that get implemented in everyone, every protocol, but they are always implemented in a different way, right? Because every architect has its own trade-offs. I'm building for retail, I'm building for corporates, I care about decentralization, I care about time to market. So it's built different. And I have the article in front of me. I need notes for this. And I have 7 points. And those 7 points, the 7 fingers, is where is the money going to be kept? The users are going to give us collateral. Where are we going to keep it? How are we going to know how many funds did the user give us and how much debt did we issue? Bob gave us 1 Ether and we gave them 1,000 DAI. We need to record that somewhere. How much are we going to charge in interest? There needs to be a function there. Since these are over-collateralized loans, means that we need to make sure that the user is giving us more assets than we are giving them, right? We are keeping the upper hand in here. So we need a function that tells us the Ether that Bob gave us is worth this much, right? And the debt of Bob is this much. So, okay, he still has enough. We need a way of kicking Bob out of the system and selling his collateral to clear his debt. Because if not, there is a bad debt for the protocol and we go bankrupt and everyone loses their money. Not good. There needs to be a risk management system. This is number 6. There needs to be a risk management system because there are some limits that might not be very safe. For example, it might not be wise to lend $1 billion of DAI, right? Because maybe if you lend that much and you have to liquidate it all, it cannot be sold on the markets. Or other things like, for example, how much DAI am I going to lend you for each one of your Ether? Right, so that's the risk management part. And finally, you have to put an interface in there. How are the users going to use all these functions, which is borrowing? Basically, users want to add collateral, remove collateral, borrow, and repay. It's those 4 functions. So you need to put an interface for that. So it's only those 7. I don't know if anyone followed me. Keeping notes, the article is good. But yeah, basically is taking the money, keeping track of it, making sure that the user is healthy, liquidating him if not, and giving users an interface. That's how everything is built.
Yeah. So it sounds like the 2 points there I want to call out are 1, every version of these protocols is basically like V1 is an implementation to see if something works. And then it's sort of honing in and tweaking the protocol to make it more efficient or, whatever the goalpost is. So that's 1 point. And then your second point around there are really these like 7 different components that make these systems possible. I think just before we dive into the beginnings of sorts with Compound V1, maybe you can give, just like for people who don't know, a very brief overview on what it means to be over collateralized. And just, you kind of mentioned getting liquidated and what actually happens there. But for anyone who isn't familiar, can you give a little bit of context there?
Yeah. Basically, the same as when you go to the bank and you ask for a mortgage because you are going to buy a house. The bank will give you the money, but the bank will say, if you don't pay, I'll keep the house, right? So the house is the collateral. And the bank will make sure that the house is worth more than the money that the bank is giving you. Because if you stop paying and the bank needs to take the house and then sell the house, the bank doesn't want to make a loss. So that means that the house needs to be worth more than the money that the bank is giving you. That means that your loan is over-collateralized. The collateral, the house, is worth more than the debt. In DeFi, it's the same. You are giving me Ether, and I'm giving you DAI. You are giving me Ether as collateral, and are borrowing DAI from me. I'm going to give you less DAI than the value of the Ether that you are giving me.
And one recurring conversation that I have with friends that are not into crypto is, why would anyone want to do that? Because in this case, in DeFi, it's, you have to put up money in exchange for borrowing other money. So who is the target user, at least at the moment? I think over time, we'll probably see new types of users, but like, who has been using DeFi?
Yeah, so right now, all across DeFi, the most common profile that is using this is the degen type. We don't see many mom and dad businesses or mamas and dads borrowing on Ethereum. It's mostly people with more of a trading mindset that, for example, have Ether and think that Ether is going to go up in price, but have an investing opportunity there with DAI. right? And they know that if they lend DAI in this platform, they're going to get a 7% return on their DAI. I got Ether that I think is going to go up in price, but if I have DAI, I can get a return. What do? I don't want to sell the Ether because I think I'm going to get a return. So I put the Ether as collateral. I pay a small amount of interest to borrow DAI on my Ether, and then I put the DAI elsewhere. I get the upside of investing the DAI against the downside of paying interest, but I also get the upside of Ether prices if they go up. That's the basic process. Second one, which is even more degen, is leverage. There is staked ETH in Lido or Rocket Pool, depending what you prefer. You put your Ether there, and you get staked ETH that has a 3, 4, 5, 7% return. You can go then to a lending platform and put the staked ETH that you got and borrow more ETH and put it as well. And the staked ETH that you get again, you put it and borrow more ETH. Basically, you are leveraging. You are taking more risk, and instead of getting a 7% return on your Ether when you stake it, maybe you get a 15 or a 20% in exchange for the risk that if something goes pear-shaped, you have much more chances of losing it all. So currently, the borrowers are degens. Hopefully, in the future, the borrowers will be people like normal people, retail users, or DAOs, or corporations, or the government, someone.
Yeah, that makes a lot of sense. Yeah, and I think once we get to the end of the timeline, maybe we can hear your thoughts on what the future looks like. But let's start back at the early history of DeFi, and we'll go through the timeline and talk through each of the innovations that have occurred. So your timeline starts off in 2018 with the beginning of Compound V1, and they introduced this concept of a money market. So why don't we start with that?
Yeah, and okay, please note that Compound V1 was not the first, probably was not the first. I don't know if it was the first money market. Maybe it was the first money market, but there are probably some priors. There are always priors. And keep track of the 7 things that are going to appear in each one of all these versions and how each one gets to a more refined form. So Compound V1 was a proof of concept of we can build a money market on Ethereum. What's a money market? Some people lend money, some people borrow money, and that's all self-contained, right? It's basically that. The users lend money, the users borrow money. That's all of it. And it should be self-sustaining in the sense that the users that borrow money pay more interest that is paid out to the lenders that borrow money. So all that comes together. And that's done in a... Compound V1 was not super decentralized, but at least it's on Ethereum. That was the main innovation from Compound V1. It was just that. It's like, we can build a money market. We know that there are borrowers, we know that there are lenders, and they will borrow and lend to each other. Compound V1 was very simple. It was a single contract that had it all. It had the treasury, it kept the money, it had the accounting, it had the risk management parameters. The only thing that was outside was an oracle. But I don't remember exactly right now how it's implemented in Compound V1, but it's the only external connection. Right? You have the money market, and you have an external connection to an oracle to get prices. Why do we need prices? Because we need to know if the Ether that we were given as collateral is worth more than the DAI. I don't know if Compound had that the DAI that was given out as a loan. Probably was not DAI because I think that DAI didn't exist yet, but it could have been something that would have been there. But that's it. Compound was a very simple, single contract money market with a connection to our oracle. That's all it did. And it worked.
Yeah. So would you call Compound monolithic in that sense?
Yeah, very much. It's a single contract that took prices from an external oracle. It's the definition of monolithic.
And then from there, we go to something that is a little bit more complex, which is Compound V2. Maybe you could talk a little bit about, like, this system seemed to have worked. What was the need for evolving? I mean, of course, there's always evolution that is helpful, but what catalyzed that evolution?
So you see that from Compound V1 and Compound V2, there was actually not that much time. There was not even a year. I cannot say exactly what was the catalyst because I didn't work on Compound. But the fact that it only took them about 8 months to go from V1 to V2 tells me that they probably saw that, okay, V1 works, it does what we want, but it's not good enough, right? It's way not good enough. and we need to start working on Compound V2 immediately. That's what happened to us with Yield. And I think that between Yield V1 and Yield V2, they were about a year as well, maybe a little bit less, because we released Yield V1. And in 3 months' time, we said, okay, some parts are good, the rest is unusable. We need to go in V2. Probably the same happened with Compound V2. They saw probably quite early that this works, but it's completely wrong. So that's what I think. Then Compound V2, it did a lot of changes. Compound V2 was not the monolithic single contract with an oracle, very simple kind of thing. It introduced tokenized positions, tokenized lending positions, which was a great idea. I think that the idea is actually from MakerDAO before, but anyway, then they also included it. So basically, I'm giving you Ether as collateral to borrow. You are giving me interest on the Ether I'm giving you at the same time. So basically, I'm lending to you and then I'm using that lending position to borrow. What compounding did there is when I lend to Compound gives me a token. Doesn't just say, okay, I have a record here that says that you have given me 1 Ether. No, it's going to say, I'm going to give you 1 C Ether, 1 Compound Ether, which tells that you have a lending position. And that was revolutionary in a sense, because that means that I can lend to Compound and I have a token that integrates with any other protocol that uses ERC20 tokens. So basically, I can lend to Compound and then use my lending position as collateral somewhere else, for example. Or I can get my lending position and trade it on Uniswap. Or I can use this ERC20 token and it will fit in any ERC20 hole in Ethereum. So tokenizing collateral there was very important, and that opened the gates in a way to yield farming, along with the other great innovation from, well, Compound V2 had lots of great innovations. Another one that I think that they didn't expect would be so successful is liquidity mining, which had been introduced by Synthetics a little bit before. So it doesn't even appear in the white paper, but they say, we are going to put some liquidity mining in here and we will just give comp to lenders and borrowers. And the tokenized lending positions, along with liquidity mining, basically made the whole yield farming era happen. It was all Compound V2 emissions.
Yeah, it turns out that when you combine composability and on-chain rewards, you end up with something that is quite powerful.
Mm-hmm. It's like the leveraging thing I said before. Basically, you are giving free money to people. You are giving money to people by giving the rewards. But then you are also giving them the chance to leverage that. Because what people were doing is like, okay, I'm getting your C Ether and I'm going to put it here to get more Ether that I'm going to give you again. And I'm going to leverage on your rewards. So
that type of thing, just to take one step back for a minute, I feel like this is where you really start to see DeFi emerge as a different beast from TradFi, in the sense that anyone has access to leverage in a way that is just traditionally not really possible for retail investors. And so it feels like this is really where you start to see the unlock in, and of course, we'll talk about DeFi Summer following this, but it feels like this ability to lever up was really where things started to get crazy.
Yeah, it's the thing that in blockchain, you can do things that you cannot do in traditional finance, for starters. And I used to work for a bank for many years, for several banks, and you have like 10,000 or 40,000 people to get this bank going. And a regular DeFi startup is half a dozen people. So you have a lot more innovation happening because each half dozen guys are going to try something new. And that's what happened here. It's like, okay, we can try this and try this. That doesn't really happen in traditional finance, collateralized lending positions, and we're going to give rewards and we are going to see what happens. And this happened. Compound also had a couple more things before we move on to next one. Compound V2 had the governance thing, which was copied by everyone, but that's outside our scope. Was great. And it was also very complex. It was incredibly complex. Every time that I go into the code base, my head just spins. It's really, really hard to follow. But they must have done something right because it was forked like 1 million times.
Yeah, specifically the governor contract. We see it everywhere today. It is pretty wild just how much was kicked off. It's hard to describe what it was like at the beginning of DeFi summer, but like there was such clear excitement, especially on crypto Twitter, of people recognizing that like something was happening and we're not totally sure what it is, but there's a snowball and it's picking up speed. Was there anything else with Compound V2 before we move on?
Yeah, since it's what I said in the article, it's actually very interesting to see the architecture of Compound V2, that in V1 it was a monolithic, this contract does everything. And in Compound V2, they went the other way around. It's like, okay, so each C token is going to keep the funds of the users that they put as collateral, and it's going to keep the accounting on each C token. And then we are going to move the risk management to this completely separate contract that is the controller. That's going to do the risk management. And then somewhere there is the collateralization ratio. I think that's also the controller, but I actually don't know. I don't see it in the article. But yeah, basically when Compound V1 did everything into the same contract, Compound V2 said, okay, let's try the opposite and spread each function in a separate contract, sometimes like splitting the same function into a million contracts and just spread maximally. So they went the other way around. And we will see with V3 what happened after.
Yeah, one thing I appreciate about this article is you've put a lot of work into diagramming each of the versions of this. So we'll definitely link this in the show notes. And I hope people look at a lot of the visuals here. It helps you really understand just how each of these protocols are set up. So we're still in 2019. This sort of kicked off a lot. And I think a lot happened in a very short amount of time after Compound V2. So next was Aave V1 introducing the concept of pooled liquidity. So why don't we start with that?
Yeah, so Aave V1 came just after Compound V2. And basically, the one problem with Compound V2 is that when you give your assets to Compound V2, they end spread along a lot of contracts. So if you give Ether as collateral, it will end in the C Ether contract. If you give DAI as collateral, it will end in the C DAI contract. So all the funds are spread all over the place. And that is very inefficient for the protocol itself, that then wants to lend the collateral that what you have lent to the protocol has to lend it to other users, the borrowers, right? And that's very inefficient when everything is spread all over the place. The main innovation from Aave V1, which was a proof of concept, in a proof of concept you have one idea, and you implement one idea, is we are going to actually bring all the assets together and we're going to be a lot more efficient than Compound V2. That's what they did. Yeah, and then the architecture they did for that, it was a little bit of a mess because it was a POC. So it's like, we're going to try this idea and we just put it out. And it was a bit of a mess. You can see the same functions. So you have the business logic in one contract, then another contract has the treasury and the accounting and the risk management. That's fine. But then a separate contract has the health formula that also checks with the oracles. Yeah, you could have merged that. But that was not the point. The point of the POC for Aave V1 is we are going to put all the funds together and we're going to be more efficient because of that. That was the V1.
Doesn't the protocol lose the benefit of those C tokens that Compound introduced by going sort of the other route of like pooled liquidity? Or did Aave V1 figure out a way to sort of like find a middle ground here?
No, there's a middle ground. I mean, you can have a single contract that keeps the funds, and then you can serve any kind of token to recognize that. So you have the treasury contract, and you can still mint C Ether and C DAI and C whatever. It's just that physically the address that is the owner of all those funds is the same one.
Okay, so it's still the same functionality, just consolidated.
Yeah. It's the difference between the treasury function and the accounting function, right? The treasury function is in one contract, that's who keeps the money. And the accounting function is actually spread because it's many ERC20 tokens, which each one of them is kind of a table that says this guy owns this much, meaning that this guy has lent this much.
So the pooled liquidity side of things, was there a concern around understanding risk? Because when you aggregate these things together, that's very different from like slotting them into each independent instance, of a contract, right? Yeah. Or is it sort of all the same risk?
I'm sure that there were concerns and that they thought long and hard. We did when we were coding Aave V1 because we had the same question, like, do we put all the tokens in the same contract, and then if that contract is hacked, all the tokens go away? Or do we spread the tokens in different contracts, and that way, if we get hacked, it's only part of the funds that we lose? We decided to spread them. Aave decided to not do it. Now, in hindsight, I think it actually doesn't matter. I don't think that you're actually less safe because you spread the funds, because even when you spread the funds, you will probably spread them using some kind of factory, and all the contracts will be exactly the same. And if there is a bug, it will be in all contracts, and you will be in trouble anyway. But yeah, I'm sure that they did take this into question, and they just decided to go this way, because when you design an application, you have all these questions, and you will go A or B. And the next guy that designs a different protocol will have a different CEO, it will have different users, and where you choose A, they will choose B because the risk appetite is different.
Totally. Yeah, that makes a lot of sense. It's like either one big honeypot with a single key, or it's many honeypots with also the same key. So regardless, if you have the key,
yeah,
everyone's in trouble.
There's lots of nuance there. And yeah, it's cool to see the timeline. And you see that from the time that Aave V1 that was published until Aave V2, there is about 2 years, right? That tells you that the POC Aave V1 actually worked. It's like they were able to milk that platform for 2 years without being constrained. So they nailed it there. The next one would be MakerDAO. Yep.
Yes. Yep. And they introduced the concept of multi-collateral DAI. And actually, even before they did multi-collateral, maybe you could start with single collateral.
Yeah, single collateral is outside this graph. I actually don't know what year was released. I think it was 2017 or something like that. As I remember, you would get, I was not a user even, but as I remember, you would mint Psi out of Ether, and that was the whole thing. And yeah, you see the contracts, and they were already going the maximal spread policy of MakerDAO, where you get every possible function in a different contract and with all the funny names that I love. But yeah, basically, the main difference between MakerDAO first and second version and Compound and Aave is that Compound and Aave, they take your collateral, Ether, and they issue you a loan in some other existing ERC20, be it DAI or USDC or whatever. They're kind of in the middle. They are a kind of derivative in a way. They are not making up anything. They're just lending you what they have. MakerDAO, on the other hand, is very different. They aim to do a stablecoin, and to make that stablecoin work, they take your collateral and they create a stablecoin out of thin air. They are originators, right? They are not lending you something that someone else has given them, like Compound or Aave, that they lend you what someone else has given them, and they charge an interest rate depending on supply and demand. MakerDAO, they are going to give you DAI or Psi from an infinite source, right? And they are going to decide themselves what interest rate to give or to charge and so on. So it's kind of a more radical experiment, more complex, but at the same time, it has the same kind of 7 or so functions. With MakerDAO, you have to choose where to keep the funds. In this case, in the joins, maximally spread, not like in Aave. You have to think how to charge users when they take a loan from you, which is DAI. They have their own very complicated system for that. They have a system for liquidations with a fun name. It's the dog, the cat, the flipper, the flapper, and the flopper. Lovely. They have the same 7 things, right? And you can map them up. But yeah, MakerDAO was very special in the sense of being the first originator of something, and that they decided to take an approach to everything that was different to everyone else, right? It was maximally spread. They came up with their own oracles. They came up with their own way of doing interest rates. They came up with their own special user interface, which is awful. But for the rest, MakerDAO is great, and they are still alive, right? Since with no new version since 2019, they have been for 4 years at it without any need for a major overhaul. They have changed the liquidation system and other things, but I mean, bravo.
Yeah, I also want to chime in and like give Maker additional props because I think people also see them as sort of one of the first successful implementations of a DAO in a sense. Like I think from the original DAO, fast forwarding all the way up to MakerDAO, I think people were experimenting, but I don't think anything saw the success that Maker did. I looked up the date of single collateral DAI, so it was 2017. And so they went from 2017 all the way up to 2019 with introducing crazy new innovation. And then in 2019, they allowed people to bring any other asset and mint. And yeah, I mean, that was one of the first protocols that I learned about, and learning about like the levers that the protocol can pull in terms of adjusting interest rate to help stabilize it. They just did a ton. So I got to give them a shout out.
But look, the real insight from this article, that is the thing that made me excited and is very applicable to MakerDAO, is that if you know what you are looking for, you actually can understand these very complicated protocols quite easily, right? Once I had done this categorization for Maker that I understood and yield that I understood, and Compound V2 is like, hold on, this is incomplete. I need to do it also for Compound V1, Aave V1, and so on. But I knew what I was looking for. So I could go, okay, so Compound V1, where is the treasury? Here. The accountant, here. Where's the oracle? Here. Okay, so this is how they do it. It all maps out. You can go to MakerDAO and just track all those functions, and you will have a mental image of how it works, which is great.
It's like you know all of the ingredients that need to exist, and you're just kind of mapping them out. So then Maker, of course, introduces multi-collateral DAI and
modular architecture
evolution. Yeah. Yes. And then we get DeFi Summer, which I want to make sure we cover. Any context before we go into DeFi Summer?
I don't know. I was not at Digentem. I was not at all, actually. I had just started working in Yield by then. I was not even on Twitter. I didn't know who the Degens were. I just knew my own nerd niche. And I was building this thing, and I could see all those weird characters going mental on the corner. It's like, what are they doing? I have no idea. And I would go back to coding. So I missed DeFi Summer completely.
But a lot of this stuff kicked off DeFi Summer, of course.
Yes.
Including, like we talked about, leverage, composability around these things, more liquidity, potentially using things like pooled liquidity, all of those types of things.
Yeah, I know all that now. But at the time, I had no idea. At the time, I was just in my cave coding, and I had no idea what was going on. That's also a reason why Yield V1 was so inadequate in some senses, because I hadn't been looking what everyone else was building, and I just made it all up, and it didn't work that well. But yeah, DeFi Summer happened because of Compound V2 and all this comp, and because MakerDAO making a successful stablecoin, and because of Uniswap that would allow to trade tokens. And all those things kind of reinforced each other, so that people would be giving rewards following the model of Compound, or leveraging the rewards from Compound and from the other ones. And that was DeFi Summer, basically. All this yield farming craziness that I missed.
Yeah, honestly, you probably saved yourself some money, because I think what people learned through DeFi Summer, there was a time period where you could basically throw money at anything. People were making a ton of different vegetable tokens. And some of them were introducing cool ideas, and some of them were just straight up Ponzi's. And there was just a lot of money going around. And because all of the prices of crypto were going up at the time, it was drawing more people in, and it created this kind of flywheel of liquidity. But that can only really last for so long. And, you know, at a certain point, we just started seeing tokens breaking, and these degen vegetable tokens start to evaporate very quickly. And that sort of leads us to the end of DeFi Summer. I mean, I think there's probably a lot more to even dig into with that. But was there anything else that was introduced during 2020? I see that's sort of like a gap in the timeline.
Probably. This is not comprehensive. I just worked on the ones that would spring to mind. I haven't said anything there about proxies. I haven't said anything there about flash loans. I haven't said anything about liquidations, which is a completely separate article. Yes, there are lots of gaps. I mean,
okay.
We could be talking here for a lot long of time. I'll read more articles, okay, and explain it.
You can only fill so much into a single article.
Yeah.
And then why don't we jump into 2021?
2021, that was us, Yield V2 and Aave V2. So Yield V2 is still alive. It's winding down, but it's still alive. It's the illegitimate child of Furucombo, Uniswap, and MakerDAO, where you have components from all of them. So we took from MakerDAO how to do lending and borrowing. And what you borrow out of Yield, you would sell it in our own AMM, which is inspired on Uniswap V2, but that's out of the picture. What is important is that I and Alan, we looked at what MakerDAO was doing to build Yield V2, and we said, we like how they do the treasury spread all over the place. We are going to do the same because it feels safe. We took the same name also for the joins. They are our treasury functions, but we are going to reverse the way that users do this, because in DeFi summer is when the gas prices spike a lot, right? That's when gas was at 200 Kwei and things like that. And with Yield V1, that was a massive pain in the ass because people would be paying like $200 or $300 to just do a simple borrow. They were doing it because they were expecting some airdrop or something, but it was unsustainable. So when we went to build Yield V2, we looked at MakerDAO and we said, how can we do MakerDAO but costing a lot less gas, right? So we reversed some flows, we changed some things, we needed a lot of oracles, so we created a standard Oracle interface that we could plug different oracles into. And for the rest, we actually copied much of MakerDAO because that's what you do. Spread treasury, central accounting, a health function on the central accounting exactly the same as MakerDAO, connections to external protocols only asking on a different way. And in all that, our idea was to do MakerDAO, but instead of DAI, we are going to originate FY tokens, and we're going to have many of them instead of just one. And we're going to make this more usable, right? Because MakerDAO is awful. So we are going to streamline all the connections. We are going to put this batching router in the front like Uniswap V2. And that's it. You can see it as a kind of evolution of MakerDAO that is made to be more efficient. We traded off in security. They were maximal in security. We said, I think we will be still safe enough if we do this, and our users will be happier. So you can see Yield V2 as a kind of an official MakerDAO V3. You could see something like that. Yeah, and that was reasonably successful. It's alive still.
After Yield V2, we also started to see Aave V2 come out, to your point, like 2 years later, which innovated more on this like collateral as a token and debt as a token. So maybe you can talk a little bit about that.
Yeah, so the collateral as a token is the same as Compound had been doing with V2, and they saw it was good, so they took it. It's like, yeah, lending positions can be traded. That's great. We will do that as well. And since we're at here, we will also tokenize the debt positions to see if people will trade dev positions. People didn't. So no one is doing that anymore. But apart from that, the architecture of Aave V2 was still pretty similar to the Aave V1. They streamlined a few things. It's a little bit more sensible. You don't have stuff spread so much, but you still have the same pool liquidity. Basically, the major innovation from Aave V2 was to tokenize collateral and debt. And that kind of with Yield V2, so you get MakerDAO, Aave V2, Yield V2, Compound V2 in a way, and you get kind of an era of people were doing things in a certain way. We were still trying to be modular. We were trying to pool liquidity. We were trying to get volume and traction. Then you get to the last part of the protocols, what we have now, Compound V3, Aave V3, and Euler, which are the ones I marked there, which are each one of them going into a separate direction, saying, okay, we know that these things are successful, but they would be even better if you did them this way. And each one of the three has taken a different direction to see what's the next step, right? So Compound V3 said, okay, we are enormous. We have so much traction. We are great. What we are going to do is to reduce the risk of a hack bringing the whole house down. So we are going to actually split the liquidity again, because we are big enough that we can do it. And we are going to do separate money markets. So we're not going to be monolithic anymore. We are going to be siloed. And at the same time that we are siloed, we are going to go back to that single contract design that we had at the beginning, but now we know how to do it properly. So we are trying to make a kind of Uniswap V2, but for borrowing and lending. That's what Compound V3 is. That's what MorphoBlue is, that is coming out right now. It's the same kind of factory that creates a new money market for each one, which has minimized governance and so on. Compound V3 and MorphoBlue are very similar, and they go in the same direction. Aave V3 decided a different thing. Aave V3 said the future is multi-chain. These guys have no idea what they are doing. The future is multi-chain. So they built that into the core of Aave V3. So they are going that direction, and we will see how it goes. Euler took a different direction. Said, these guys have no idea what they are doing. What you want is a single contract that will hold everything. And we are going to implement this diamond-like pattern, and we are going to be the most efficient ever. And we are going to give a ton of rewards so that we get all the liquidity. And we are going to do all these things. So they go that direction. They got hacked, but I think that's unrelated. So we are at the stage where you have all these V3s that they are each one going in one direction, and we will see what happens.
Yeah, and it feels like what's exciting here is, again, they're taking the ingredients, they're arranging them differently, introducing new mechanisms. And based on what we've talked about today, it's one thing that seems clear is that whichever mechanism does actually work, everyone will ultimately adopt in their own implementation, which I think is exciting for the borrowing space more broadly, which is just to say we're consistently iterating despite having some level of basically product market fit for a lot of these protocols, which means that DeFi is constantly changing and iterating, which is great.
Yeah, by the time the users actually come, we will be ready, I'm sure.
Yes. Well, Alberto, it was so wonderful to have you on to talk about the evolution of DeFi, or of borrowing, I suppose, in particular. But of course, a lot of that is really the evolution of DeFi. I want to make sure that we cover where people can learn more about you and Yield Protocol before we wrap up. So where can people find you, and where can people find Yield on the internet?
Well, you can find me on Twitter and on HackerNoon and on Google in general. If you just Google me, Alcueca, short name given to me by the university, is the first part of each one of my name parts, Alberto Cuesta Canada. I didn't make it up myself. The same as Georgios, const. I'm sure he also got his nickname from university. You Google me, I'm everywhere with that name on Twitter, HackerNoon, Medium, even LinkedIn. And Yield, the same, yieldprotocol.com. But we are winding down, so probably now is not the time for you to give us your money, because we will have to give it back to you, and it will be uncomfortable. But still, our code is open source. Go through it, reuse it, abuse it. I have a lot of articles in there. Read them, get educated, and ask me questions whenever you want.
Beautiful. Well, Alberto, thank you so much for coming on the pod. This was so fun.
Thank you, Alberto.
Thanks a lot for having me.
Appreciate it.